Hey guys, we are in section 2.4 and we're going to be using postulates and diagrams. Write the title, write the date, and let's get started with the notes. So the first vocabulary word we're going to talk about is postulate. And if you remember, we had this word back in like section 1.1 or maybe 1.2. You do have it in your notes. And a postulate, if you remember, is a law or a rule or an axiom, some kind of principle that we accept without proof. We don't even worry about the reason behind it because it's almost like so obvious sometimes that we're like, yeah, that's true. And we accept it without going into detail about proof. So here we have the first four postulates that you guys are probably used to. Let's take a look at these up close. These first four postulates we talked about early in chapter 1. The first one is the ruler postulate. That's just really the idea that we can assign a numerical value to the length of something, basically use a ruler to measure a segment. The segment addition postulate, that's when we took two segments, we put them together, and then we realized that the length of one small segment plus the length of the other one would give us the length of the whole long segment. That's the segment addition postulate. We also had the protractor postulate, which allowed us to assign a numerical value to an angle so that we can talk about the angle measure. And then finally, we had the angle addition postulate, which gave us a very similar power, just like we had with the segment addition postulate, where we take two angles that are adjacent, meaning they share a side. And if we add up the measures of those two angles, the sum of those two angles gives us the measure of the larger angle. You've seen those before. If for some reason you've forgotten them, feel free to copy again and we can talk about it together in class. But now we're going to turn our attention to several new postulates. So make sure you have some space and make sure what you're writing is very neat. So we're going to call this postulate number 5. Postulate number 5 basically states that if you have 2 points, there's exactly one line that can go through those 2 points. So through any 2 points, there is exactly one line. Postulate number 6 says if you have a line, there's at least 2 points on it. We know there's infinitely many points on a line, but it makes sense. There's at least 2 points on a line. Postulate number 7 reminds us that if two lines intersect, right, they're going to intersect in a point. So if two lines are intersecting, they're going to intersect in exactly 1 point. Postulate number 8 reads that through any 3 non-collinear points, there exists exactly one plane. So if you took 3 points anywhere, once they're not collinear, right, not in a straight line, but if you took 3 points, there's exactly one plane that can slice through all 3 of those points. Postulate 9 states that a plane contains at least 3 non-collinear points. So if you have a plane, on that plane, there's at least 3 points that are not collinear. So postulate 10 says if you have, let's say, 2 points that lie in a plane, then the line that connects those 2 points also lies in the plane. In postulate 11, you might remember if you have 2 planes and they intersect, 2 planes will always intersect in a line. Remember when we would draw pictures like this, planes R and L intersect in line T? So that's what postulate 11 is talking about. If 2 planes intersect, those planes are definitely going to intersect in a line. We've got one more vocabulary phrase and a couple more concepts, so hold on, we got a few more things to do. Okay, we're going to take a little bit of a break from writing, but we're going to talk and I need you to listen. I need you to be following with me. So you'll get this diagram in class and you'll be able to add it to your notes. So after you add this to your notes, I want you to listen to what we're talking about right now. This is about interpreting a diagram. So when we're looking at these pictures, and I'm noticing a lot of us are having a little bit of difficulty with this, we need to know what we can assume and what we cannot assume. We're going to go through these statements fairly quickly. Feel free to pause, rewind, and use your time wisely so that you can understand what we're doing. So let's go ahead and take a look. Look at the picture. This is plane P. We see that there's some lines on the plane. There's lots of points. You can see that the plane is in blue, and we can see that there's 3 lines that are drawn, but we know there's more lines because any 2 points is contained in a line. Let's go ahead and talk about what we've got. All points shown are coplanar. Remember what the word coplanar means? It means on the plane, and that makes sense because every point here, P is not a point, it's the name of the plane. Every point here is coplanar. Angle AHB, and angle BHD, that's these two angles right here, are a linear pair. Let's look a little bit closely and see what they're talking about. So when I zoom in, a linear pair are two angles that are side by side like this. We call them adjacent. So here's one angle that I marked, and I marked this one with two lines. These two lines form a straight line, and so that is exactly what a linear pair is. And angle AHF, that's this one down here, and angle BHD are vertical angles. Let's go ahead and make sure we know what that means. Vertical angles are those bow tie angles. They're right across from each other. So that's this one. AHJ and D, they're on a line. They are collinear. Line AD and line BF intersect at H. Let's go ahead and take a look. Line AD, that's this one, and BF, they intersect at H. And here's some things we can't assume. So all of that, just by looking at it, that information is given to us. Here's what we cannot assume, that G, F, and E are collinear. Let's look at that, G, F, and E. We can't assume that these 3 points are collinear because there's no line explicitly drawn through it. 2 points are always collinear, 3, not so much. BF and lines BF and CE intersect. Let's look. Lines BF, BF, and CE. I don't see where they intersect. Maybe later on they would intersect if I extended them, but I don't see that, so I can't assume it. I also cannot assume that they do not intersect. Like I said, I only see that they're going in a direction, but I can't assume that they don't. Here we have also the angle BHA, that's this one here, and CJA, that's this one here. I cannot assume that they are congruent. I don't know. And finally, I also can't assume that AD is perpendicular to BF. That's what that upside down T means. It means they form a 90-degree angle. And I can't assume that angle AHB is a 90-degree angle. So some things we can assume and some things we can't. This is important for you to know, especially moving forward in geometry. So here's our final vocabulary word before we get into our examples. A line perpendicular to a plane. Here we have line T, and it is perpendicular to plane A. What does that mean? What it means literally is that line T is going to go through the plane such that any line in the plane that crosses through or intersects T, any line in that plane will also be perpendicular to line T. So in this case, we could say that this line is perpendicular to the plane. So here we're at example 1. We're going to talk about identifying some of these illustrations by using the postulates. This first one, it says, if you've got this situation, then this. If you've got two lines that are crossing each other, then, this looks like one of the postulates we talked about. Let's go back and check it out. I think I found it. It looks like postulate 7. It says if two lines intersect, then they intersect in exactly 1 point. So let's go ahead and write that down. So if two lines intersect, then they intersect in exactly 1 point, and that's postulate 7. So let's look at part B. Part B has two planes that are intersecting, and then we see this line situation. I think I know which one this is. You might have been thinking exactly like I was. Postulate 11, if two planes intersect, then those planes intersect in a line. We're going to write that down. If two planes intersect, then they intersect in a line. Let's go on to example 2, y'all. Identify postulate from the diagram. Use the diagram to write examples of postulate 9 and 10. All right, let's go ahead and refresh our memory about what 9 and 10 are. So I grabbed postulates 9 and 10 so we can talk about this. A plane contains at least 3 non-collinear points. Let's look and see if we can find in plane P 3 non-collinear points. We've got B and A, they're collinear, but altogether BA and this other point C are non-collinear. So there we have it. We've got B, A, and C to talk about or to show postulate 9 is true. So that's what we would do to emphasize that concept. Let's look at postulate number 10. Postulate 10 says if 2 points lie in a plane, then the line containing them lies in the plane as well. So let's see if we have that here. We've got 2 points. Again, we're looking at plane P. We've got B and A lie in that plane. And also notice the line N that contains B and A lies in plane P. So I'm going to write that down. So plane P contains points B and A, and line N contains points B and A. And so plane P also contains line N. All right, let's go on to the next example. So in example 3, we're asked to sketch the diagram of line TV intersecting segment PQ at point W such that TW is equal to WV. That's a whole lot to work on, but I think we can figure it out. Let's see what we can do. So we're given that we have some segment PQ where we're going to get this line TV that's going to cross PQ such that we get these 2 segments, TW and WV, that are congruent. Let me go ahead and draw line TW, or really line TV. We've got that there, and we're going to choose some point here. Let this be W because that's where this line is supposed to intersect this segment. And what I'm going to do is bring this line over so that I meet the condition here, TW being congruent to WV. So when I do that, let's see if I can make it happen. I'm going to grab it. Y'all with me? There, it looks pretty good. TW, that's this segment here, has to be the same length as WV in order for them to be congruent. I think we did a pretty decent job. One thing that's really important in geometry is for you to be able to picture and draw what you're being asked to think about and look at. One more example with me, and then you guys have some on your own. Let's take a look at this last one. It says, which of the following statements cannot be assumed from the diagram? So let's go ahead and take a look. That A, B, and F are collinear. Let's look. A, B, and F. Are they collinear? Can we assume that? Collinear means they're on the same line. A, B, and F are on the same line. So that is not the statement we're looking for. I'm going to cross it out with just a single line. Let's look at this next statement. E, B, and D are collinear. Let's look at that. E, B, and D. Since there's no line going through all 3 of those points, this is one that we cannot accept as true. So I'm going to put a check mark next to it. Let's look at this next one. AB, segment AB, that's right here, is perpendicular to plane S. Well, we see segment AB is perpendicular to this line in plane S, so that gives me the right and the ability to say that it is indeed perpendicular to plane S, so that is not one of the statements that we can say is not true. Let's go ahead and look at this next one. We've got segment CD. Can we say that it's perpendicular to plane T? We don't have that little perpendicular 90-degree angle situation. I don't know anything about this relationship. So this is one that I could say, yep, I can't tell, assume it from this diagram. Let's look at this final one. If line AF intersects line BC, here's AF from here to here, and here's BC from here to here. Do they intersect at point B? And from this picture, you can see that intersection point clearly. So yes, we can assume that. So I have to cross it out. There's only 2 statements here that cannot be assumed from the diagram. That's this one, E, B, and D are collinear, and this one, that CD is perpendicular to plane T. With that in mind, y'all, it is time for you guys to figure it out. You got to do these on your own. Number 3 and number 4. Make sure and have it done. Otherwise, your notes are not complete. I look forward to seeing you guys soon. Take care. Bye-bye now.